Hello everyone, you are welcome to today's class. So in this video we want to continue from where we stopped. We stopped at expansion of algebraic expressions. So today we want to look at factorization, and we're looking at the first aspect. We're going to have about 3 or 4 series under factorization. So under this, in this video we'll be looking at these two objectives. We want to look at how to find the ACF of algebraic terms. Then we look at how to factorize simple expressions. So that's what we're going to look at. So when we talk about factorization, factorization is the opposite of expansion. Don't forget how we treated expansion. For example, if you ask to expand 2x plus 3 into 2. So you have to expand this. You have to expand this. So what you are meant to do, you are meant to open the bracket. So when we open the bracket here, we're going to have 4x plus what? Plus 6. So this is expansion. So the answer of expansion will be the question of what? Factorization. That reason why factorization is the opposite of what? Expansion. So which means we are going to factorize. They are asked to factorize this. Your answer will become what? This. So we go back to this. So when you factorize, from factorization, from expansion, you come to a factorization question, and so on and so forth. So that's what we want to look at in this video. Now, before we can factorize, you must know how to find the highest common factors of algebraic terms. That is, you need to look at what are the factors that are common to terms. The factors that are common to terms, we should be able to bring out the highest common factors. So that's what we're going to learn first. So we need to understand what is the highest common factors. The way we find the ACF of ordinary numbers are the same thing we're going to do here. So ACF of algebraic terms. So ACF of algebraic terms. So before we look at algebraic terms, let's look at ordinary numbers. So let's look at how we find ACF of numbers. Find the ACF of 12 and 62. So we want to find the ACF of 12 and 62. There are different methods we can adopt. So as we are adopting factor method. So we are going to express each of the numbers as products of their prime factors. So we express 12. So 12 will become, we find it 12. 2 can go in 12, that is 6. 2 can go, that is 3. 3 can go. So this will give us 2 times 2 times 3. Then it remains 62. 62, what can go is 2. 2 here, 3. 2 here, 1. So 31 is a prime number. So in that case, this will also be what? 21. 31, which is equal to 1. So this will become 62 will become what? 2 times what? 31. So what will be the common factor here? So what is common to this number and this number? The factors that are common is only what? 2. Therefore, the ACF is also what? Is equal to 2. The same way, or you do it this way, you can combine the two of them together. Either of the two, you still going to get the same thing. 12 and 6. So what is common is 2. 2 here 6. 2 here 31. So nothing again that is common. So ACF is what? Is 2. I hope it's very clear. So the same thing will be done under the ACF of algebraic terms. I hope this is clear. So let's now look at examples under algebraic terms. So we have these examples. So find the ACF of the following. We have these 3. So the first one, solution. So we have 4a squared b squared y and 2a cubed by squared. Let me divide this into 2. So what we're going to do first, so applying the method I just showed you now, we can apply both methods here too as well. So what we're going to do first, we want to express this as products of its prime factors. Let's want to break this down. So we have 4a squared b squared y. So this 4 will be what? 2 multiplied by 2. A squared is a times a B squared is B times B, and the Y is what? Y multiplied. And the second one, we have 2A cubed BY squared. So that is 2 times A cubed will be A times A times A times B times Y. So from here we now look for common factors. So what are the factors that is common? 2 is common, so I'll write 2. Times A is common as well, I'll write A. Times A is common as well again, I'll write A. So we have A, we don't have A again. We have 2 here, we don't have 2 here. So it's not common. Then B is common, right? So multiply by B. B is here, we don't have another B again. Then we have Y here and then Y here. So that means multiply by 1. So the HCF will then be the multiplication of all this here. So this will be 2A times A, that is A squared, B, Y. So that is the HCF of these what? Algebraic terms. I hope this is very clear. Alright. So that is that on the first method. Second method, we can do it straight. What do I mean? So you have this way. So let's write this here. 4A squared B squared Y, then 2A cubed BY squared. So we'll look at what can divide. 2 can divide here, that is 2. Repeat A squared B squared Y. So 2 has gone, remains A cubed. Because 2 divided by 2, that is 1. So it remains A cubed BY squared. So what is common again is A. So this one, it means to remain 2. When you divide A squared by A, so this means A times A divided by A cancels, it remains A. So this will remain A, while this is B squared Y. So this will remain what? A squared BY squared. So this means that A cubed divided by A, which means A times A divided by A cancel, it means A squared. That's why this one is A squared. So what can go again? A is still common to both of them. We use A again. So this will remain 2 B squared Y. This will remain A BY what squared. So A cannot go. We have 2 here, we don't have 2 here. We have here, we don't have here. So what next is B? B, we have, this will remain 2BY, and this will remain AY squared. I hope I'm making sense. So what next? B here, no B here. Y. It's only Y that is left. So this will be Y, and this will be 2B, and this is going to be AY. So there's nothing that is common to them, so then we stop there. So that means the ACF will then be the multiplication of everything here, which is going to be 2 times A times A times B times Y. Then you get what? 2A squared BY, which is the same thing with this one. So in example, you can make any use of any of these two methods. You still get the same thing. But the most important aspect of it is that if the question is objective question, I will advise that you go through this, because the process of separating all this one might take you some time. But here, it's straightforward, you get your answer. I hope this is very clear. So from here now we can go to example number 2, and that one we can use any of the two methods to solve it. So I will use the second method to solve this, and I'll use the first method to solve this. Is that clear? So we have 3, so that's going to have 3 columns. So the first is 3x y squared 9x y cubed. Here have 12x squared y squared. So the first thing we look at the numbers. The number that can go in 3, 9 and 12. So it's 3 that can go in 3 of them. So 3 divided by 3 is 1. That means we're going to have x y squared left. 3 in 9 is going to give us 3x y cubed. 3 in 12 is 4x squared y squared. I hope I'm making sense. Alright, so the next, there's no number that can go in the 3 of them, in the 3 terms. So the next, we look for the next, which is x. So x can go in 3 of them. So x this will remain y squared, this will remain 3y cubed, and this is going to remain 4x y squared. So what next can go is y. Y can go, this remain y, this remain 3y squared, this remain 4xy rather. I hope you understand how I got this y. So this means y squared, which is y times y divided by y, so remain y, that is it here. Y cubed, so which is y times y divided by y, so remain y squared, and so on and so forth. Is that clear? So the next thing, if you look at this, what is common again is only y. So y is common here. This is 1, this will be 3y, and this is going to be 4x. Do we have anything common again? So no. In that case, our ACF here will then be equals to 3 times x times y times y. That gives us 3x y squared. I hope this is very clear. So that is that, how to find the ACF of Algebraic terms. So let's look for the third example here. The third example, we have 2 pi, you can see the pi r squared, and then 2 pi r squared. So the r's are not the same. So don't make the mistake, the r are not the same. So what we're going to do, we're going to express each of them as products of their prime factors. So this will be 2 times pi times r times r. The second one is 2 pi small r squared. That is 2 times pi times r times what? R. So the next is to find the common factors. So common factors are 2, right? And then pi times pi. Any other one? No. So that means ACF here will then be equal to 2 pi. I hope this is very clear. So that is that on ACF of algebraic terms. So let's now look at factorization of simple algebraic expressions. Alright, so factorization of simple expressions. I've explained earlier on that factorization is the opposite of what? Expansion. Meaning that we want to introduce brackets. So we're going to, our answer must involve what? Brackets here. So let's start with the first one. Before you factorize, the first thing you should do is to bring out the highest common factor of the two terms you have in the expression. Because in an expression, solution, in an expression, you have different terms. So this first expression we have a 2xy plus xyz. This is an expression, algebraic expression. But this one here is a 10, and this is another one, 10. You understand? So the first thing to do is to find the ACF of the two terms. We find that, and that's what we just concluded now. We've learned that. So that can be done in two ways. So either you use expressions of the term by the product of their prime factors, or you use the column method. So how do you do that? So let's first of all do this. 2xy, where that will be 2 times x times y. While this is x, y, z, it was x times y times what? Z. So from here we can bring out the common factors, which will lead us to the highest common factor of the two terms. So what is common to this and this? X is common. That will be first one. Common factors is x. Then y is also common. That is what? Y. So which means the ACF is what? X, y. I hope that is clear. So after that, we can then come back to the question, which is 2xy plus xyz. We then factorize this. So now bring out the highest common factor that we just wrote here. Bring it out, xy, open a bracket. Please take notes. Please take notes. Don't rush yourself. So the first thing is to find the ACF, which is this, xy. The next thing is to put the ACF outside a bracket, open the bracket, then bring the first term you have here, which is of 2xy, divided by the what? The ACF, xy. What we have then is plus x, y, z, divided by the ACF again, xy. So you can then say y can go here, x can go, x can go, y can go. So what we have left will then be xy into bracket 2 plus what? Z. So this will become the what? Answer. Can I see that we have bracket in our answer? That means it is the opposite of what? Expansion. If you expand this is what you're going to get. So xy times 2 is 2xy. Xy times z is what? Xy what? Z, as you can see. So another method we can adopt here, we can as well adopt the column method to solve this. Method 2. You get your answer straight. Method 2. So what we just need to do, put the columns here. So this is 2xy. And the second one is x, y, z. So we look for what is common. X is common, that's the first thing. You have 2y left. Then we have what? Y, z left. Am I with you? Then the next one is, what is common again is y. So we have 2 here left and z left. Nothing is common again. You can see now that we have our ACF here. So we just, what you're going to do is just put your x, y here, open a bracket. What you have left here, that nothing can go again, which is 2. Then what we have between the two terms is what? Plus. Then what you have left is what? Z. Straightforward. You can see we have the same answer here, right? So that means you can see this is faster than this, right? This is faster than this. So you can adopt this one in any exam, whether objective or theory, you still get your what? Same answer. I hope this is very clear. So we move to example 2 now. Example 2 here. So we'll apply this method straight. Let's apply this method straight for example 2. We have 17m minus 34m squared. So we have this. This is 17m, then 34m squared. Now if you look at this, there's not, it's 17 and 34. You have to be very careful, extraordinary careful, because sometimes you look at some numbers, you'll be thinking that you don't have common factors. 17 and 34. You'll be thinking there's nothing that can go in 17. 17 is a prime number, while 34 is an even number. So nothing can go in both of them. No, you don't have to do it like that. So when you see that, just think, can 17 go in 34? So you can just say 17 multiplied by 2 and see what you're going to get. You can see it's 34. So which means 17 can go in both of the numbers. So that means 17 here, that is going to remain m, and this will be what? 2m squared. Then what can go again is m, right? So 1, what you have left is what? 2 what? M. So in this case, 17m is our ACF, right? What we have left there is what? 1. Then what we have between the two of them is minus. Minus what? 2m. That gives us our answer. I hope this is very clear, right? Very good. So if that is the case, you can see it's very easy. You can as well adopt this method. You can adopt this method to confirm your answer as classwork, so that you see if we are going to get the same answer or not. So let's go to example 3, which involves fraction, and the fourth one, and see how we're going to solve that. For question number 3, we have bx over a squared minus bz over a plus bz squared over what? A cubed. Now the techniques we are going to use here is quite different from the one we just made. Since what we're looking for is the common factors, let's find the common factors. So what we're going to do, we look at the numerator separately and the denominator separately. So let's look at the numerator. So the numerators here, we have b here, we have b here, we have b here. We have x here, no x, no x. Z here, but no z here. So which is the common factor at the numerator here is what? Is b. hope I'm with you, is b. While on the denominators, a squared, a cubed. So you can as well do this so that you'll be very sure of what you are doing. Bx, bz, right? Bz squared. So b is common x, z, right? That is what? Z squared. That's what you have there. Then you can do the same thing for the denominator. For the denominator, I hope you see what I'm doing. This is numerator. For the denominator, we have a squared, we have a cubed. So what is common? A, 1, a squared. We don't have anything common because care is not taking, you be thinking a can still go, but whereas we have 1 here. We have, though we have a here, we have a here, so but we don't have it. So we is not common to the 3 of them. So whatever you are using must be common to every term you have there. Is that clear? So that's what we have. So it means the common factor here will be what? B over A. Then bracket. So what we have left there is x. What we have left there is what? A. X over A. Minus what we have left there, the second one is what? Z. Over what? 1. Plus what we have left here is what? Z squared. Over what? A squared. That is it. That's the answer. Again, it's straightforward. Straightforward. So no problem. I hope this is very clear. And if you are not adopting this method, so once you bring this out, so just make sure that you use this to divide this. So how do you do that? So that is bx over a squared divided by b over a, which you can change to what? Bx over a squared times a over what? B. A here cancel this, B here cancel this. What you have left is x over what? A. That's what we have it. So you can do this. It's very simple. Just take your time to look at the process one by one. Is that clear? So let's move to the third one, the last example that we have here. The last example, we have 15 m squared m cubed n squared minus 5 n squared plus 10 mn. So the same thing will be done here. So let's express each of them. Let's use the other method. Let's express each of them as products of the prime factors. So that is 15m cubed n squared will be what? 3 times 5 times n times m times m times n times n. Then you find for 5m n squared will be what? 5 times m times n times n. Then 10 m n will be what? 2 times 5 times m times n. So common factor now. So 5 is common, right? That is 5. M is common. M. What is common? M here, you don't have M here, you don't have M here. So N is common times N. You don't have anything common again. So in that case, the ACF is equal to 5mn. That's the first part. Second part, the concluding part will then be the ACF, which is 5mn into brackets 15 m cubed n squared divided by what? 5mn minus 5m n squared divided by what? 5mn plus 10mn divided by what? 5mn. I hope I'm making sense. Alright? So, if that is the case, so what we're going to do, we divide now. We're going to divide it. So this is 5mn. So 5 cancel here, 5 here, 3. M here 1. M here we reduce on to the square. N here 1 we cancel this one. 5 cancel 5. M cancel n. N cancels the square. 5 here 1, 5 here 2. M cancel m. N cancel n. So what we have left there is 3m square n minus everything here gone except n. right? Hope you are getting it. Plus 2, nothing again. That is the answer. How this is very clear. And if we want to use the second method to confirm, you can have this. Let's have it. Okay, the first one is 15 m cubed n squared, 5m n squared, then 10 mn. So what can go is 5 in 15, 5 and 10. So this will be 3m cubed n squared. 5 divided by 5, that is 1, that is mn squared. So this will be 2mn. What is common again is m, right? So it will remain 3m squared. This m cubed. So divided by n will give you m squared. N squared. This m has gone, it remains n squared. It remains 2n. So what again can go is n. So this will be 3m squared, then n, then 2. So the HCF will be what? 5mn, 5mn. Then what is left is 3m squared n minus n plus 2. It's not the same thing. We have the same thing in the bracket. So that is how to solve that. And this is, now we've solved everything. So this is the end of this video. This is where we're going to stop. So if you are new to this channel, don't forget to subscribe and then make sure you turn on your notification bell. So anytime I release video like this, you'll be able to be the first to get the notification and benefit from it. And you can as well share the video with your loved ones. Share with them. And if you have any comments or any questions you want me to solve, I will surely solve it for you. Just put the question in the comment section. I will surely answer you. So we'll meet in our next video. Bye for now.